Solving a system of linear equations using substitution. Remember that a system of equations is really just saying that we have more than one equation. So there's two equations. We also have two unknowns. So we're going to take advantage of these two equations to solve for those unknowns. If one of your equations has a variable that is isolated, then we're going to use a common method called substitution. This is a very common practice in mathematics. We tend to substitute a lot. So why don't we get started? First thing I'm going to do is actually label the first equation to be equation 1 and the second equation to be equation 2. We're actually going to sub 2 into 1. And let's see what happens. So we have 5, then times x. But what's x? X is going to be parentheses 3y minus 7. So make sure you use parentheses when you're substituting. That's what we mean. And then minus 3y is equal to negative 11. Then you react to this and solve for y. Then we have what? 12y minus 35 is equal to negative 11. I don't like the way that 3 looks, so I'm going to make it nicer. There we go. Add 35 to the entire sides, and we get 12y is now equal to 24. Divide the entire sides by 12. We actually get y equals 2. Now, keep in mind that when you're solving equations, every line of your work is another equation. Notice your answer here is even an equation. We have only gotten one variable, and we need to find the second one. So, how do we do that? Why don't we take y equals 2 and use equation 2. So we're going to sub y equals 2 back to equation 2 to solve for x. And notice x is now negative 1. And what have you found? You actually found a set of solutions. In this case, this set of solutions only has one ordered pair. So this is actually what we say a set consisting a unique solution. And remember, it is an ordered pair, so x has to be written first, and then y is written second, and you have parentheses around that. Graphically, this is the intersection of two straight lines. So if you wanted to, you could use y equals mx plus b and graph these two lines, and you realize they have an intersection. Just for kicks here, why don't we check? Let's check equation 1. Let's look at this expression of 5x minus 3y. And let's see what this yields if x is negative 1 minus 3, and then y is 2. Let's see what this is. This is negative 5 minus 6. And what is that? That's negative 11. And so yes, indeed, equation 1 is true. Isn't that cool? Why don't we check equation 2 as well? So if the expression x, if you started with x, we just have x, it's now equal to what? Oh, we said x is negative 1. Is that equal to 3 times what? 3 times y, which is 2, and then minus 7. Let's find out. Well, if you just do some mental math there, yeah, that's true too. So yes, it checks. And if it checks, then you could actually circle your right answer with confidence.